Thanks for the internet. Hey, everybody. Thanks for coming. I hope this will be fun for you guys. I hope you learned something. I'll try to make it as informal as possible, pretty interactive, a few live demos. So yeah, let's get started. I'll share the presentation. Okay. Great. So you're at the Introduction to Machine Learning workshop. If this isn't what you wanted, now's the time to leave. Okay, a little bit about me. My name's Ahmed, machine learning engineer. I work at Elemento. We're an MLOps platform with all sorts of tools and infrastructure for doing MLOps. I spoke about it in the opening ceremony, and there's a lot of description about the company on DevPost and Kaggle as well. So I studied at New York University, studied philosophy and mathematical logic. So if anyone's interested in discussing that with me, please reach out. You can connect with me on LinkedIn or any other platform. Okay, so here's what I want to cover today. Kind of give a general overview of machine learning and deep learning, how it works, what sorts of things you can do with it. I'm going to show a few videos, a few demos. We'll try and build simple systems together. I'll kind of talk about how all the pieces of an ML system fit together. And then kind of resources you can use to learn machine learning, get a job in machine learning, that sort of thing. And then at the end, I'll talk about the competition. Elemento is hosting a competition with a lot of exciting prizes. So I'll talk about how you guys can participate in that in this hackathon. And then at the end, we'll have a pretty long Q&A session, so you guys can ask me anything you'd like if I haven't covered it. Okay, cool. So what is machine learning? Here's a really annoying quote. A computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. So if you pick up a textbook, that's what it's going to say. That's one of the most popular quotes. Below is really what you're doing. You're fitting a function to some data points. So you have some data and you want a function which generates that data or fits the data. Okay, what can you do with machine learning? So I'm going to put this link in the chat, and we're going to have an interactive demo after. But now I'm going to go ahead and show you a quick use case. So can everyone see that? If you can't, let me know. So this is something Google put together. Basically, you're going to sketch something and the AI is going to guess what you're sketching. So here's a prompt. It asks us to draw a sleeping bag. I'm going to do my best. Trying to do the zipper. Okay, I can't. All right, so it's doing a pretty poor job, probably because of my drawing. Okay, so we'll see if it can get pineapple. Get the spikes. Okay, got that one. We can do a car. It should be pretty easy. The mushroom should be pretty straightforward. So it gets that pretty quickly. Let's see the keyboard. Oh, we're almost done, so I won't bother you. I mean, so One thing to note is how it understood that that rectangle was a keyboard and how it works. Okay, so here are the things we drew. Here's what it guessed. Basically, there's just a small list of things that it's trained on. So maybe like 1,000 objects, maybe smaller, like 100. And the model is going to take your drawing as input and try and figure out which of the 100 objects it is. So it thought it was a keyboard just from the rectangle because most likely there's nothing else in the data set that is just a simple rectangle, or when they did the training data, kind of everyone just draws that rectangle. So it knew rather quickly that it was a keyboard, or at the very least, it was going to just start guessing rectangle things. Maybe there's just a few of them. This is a neural net that you can build at home. Won't take you long. And just by interacting with it in this playful way, we're actually training it. We're giving it samples. So now these will be added to its database. So I'm gonna give you guys maybe 5 minutes if you want to play around with this, and then we'll come back together and move on. I'll put the link in the chat for this if you guys are interested. So yeah, just 5 minutes on this. I'll stop sharing. Exciting. It's pretty stunning. This isn't something that you could have built 8 years ago, 10 years ago. This is something that we're only able to do now, mostly because of developments in deep learning and GPUs and all sorts of training methods. But primarily, it's deep learning. Maybe 10 years ago, they realized that making neural networks deeper and deeper seems to give you richer and richer hierarchical feature representation. And that makes image tasks pretty straightforward. It's one of the things neural networks do really well, which is classification tasks with images. It's one of their premier use cases. Okay, so let's get on with it. So what kind of problems can machine learning address? Here's some examples. You can classify an image as either a dog or a cat. That's easy. Predict age given income and weight. Turns out that this is actually a pretty accurate predictor of age. Usually people get fatter as they get older, and they make more money as they get older. A bank has to do this all the time, which is discern which financial transactions are fraudulent. So, you know, you're using your credit card all day, and then suddenly you get a message from your bank that says they've detected odd activity. They detect that odd activity using machine learning, and what they're doing is outlier detection. Another one that has large financial implications is predicting the price of a stock at time step t, given the price at time step t-1. So given where a stock is now and maybe its history, tell me what it's going to do tomorrow. Predict the GPA given number of YouTube videos watched a day and the category of the YouTube videos. This also turns out to be a really accurate predictor of GPA. You can substitute YouTube with all sorts of metrics on social media, like how much time they spend on Facebook and what they're doing on the platform and so on. And this one's a little scary, which is predict remaining years to live based on income, race, city of residence. You maybe don't think race has anything to do with it. In fact, it has a lot to do with it because of healthcare disparities that are racially based. And if you don't get good healthcare, you're not going to live as long. Income is redundant. Race and actually is the strongest predictor here, even more than income. So it's very frightening that you're able to do this. And insurance companies make this prediction all the time. When they give you health insurance, they need to know how many years you have left so that they can price your insurance. If you can do this prediction more accurately than the next guy, you're going to have higher certainty, which means you can have lower prices, and you'll be the largest insurance company in the world. So it's worth learning machine learning. Here's a pretty exciting video. Let me know if you can't hear the audio. Some context for this, what's going on is that there are two teams, hiders and seekers, and the hiders are trying to stay out of view of the seekers, standard game. And there's a few objects in the environment that the agents can interact with. But the important thing here is that the agents are being trained with reinforcement learning, which means that they're going to act randomly in the beginning, and then they're going to be given rewards or punishments, and their neural network is going to make adjustments over time, and they'll learn all sorts of complex behaviors just through what's known as self-play, which is when reinforcement learning system is pitted against itself, and it continuously improves. So none of these behaviors of these agents were explicitly programmed. They were just learned over time. So let's play this, and please let me know if you can't hear the audio.
Ahmed, I do not think we can hear your audio.
Oh no. Okay. It's not actually that important. I can just tell you what's going on.
Okay.
Can the volume be increased? It feels like it's just a little low.
Something that you can do is stop screen sharing, and then when you, hold on, give me a second.
Action and competition led to the evolution of increasingly intelligent life forms. Today, we ask if comparably simple rules and multi-agent competition can also lead to intelligent behavior in a new virtual world. These agents are playing hide and seek. These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps. However, after many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. Note that we did not explicitly incentivize any of these behaviors. As each team learns a new skill, it implicitly changes the challenges the other team faces, creating a new pressure to adapt. We've also put these agents into a more open-ended environment, randomizing the objects, team sizes, and walls. In this world, they learn to construct their own shelter from scratch, requiring that they arrange multiple objects into precise structures. To prevent seekers from using the ramps, the hiders move them to the edge of the play area and lock them in place. We originally believed this would be the final strategy that the agents learn. However, we found that after more training, the seekers discovered that they can jump on top of boxes and surf them to the hider's shelter. In the last stage of emergent strategy that we observed, the hiders learn to lock as many boxes as they can before constructing their fort in order to defend against box surfing. So how do agents acquire these skills? They're trained using reinforcement learning, an algorithm inspired by the way animals on Earth learn. The agents play thousands of rounds of hide and seek in parallel for many days. They train against each other as well as past versions of themselves using an algorithm called self-play. Coevolution and competition on Earth led to the only generally intelligent species known to date, humans. While this world is far less complex than Earth, we have found evidence that simple rules can lead to increasingly intelligent behavior from multi-agent interaction. We hope that with a much larger and more diverse environment, truly complex and intelligent agents will one day emerge.
Okay.
This thing, but the things on the right side.
Great.
I want to put it horizontally. Well, for what?
So it's pretty incredible that something like that's possible. We only started gaining faith in neural networks' ability to do tasks like that with AlphaGo and other comparable systems. Really, developments in reinforcement learning were the key to this. OpenAI, the research lab and company that did this demo, also built GPT-3, which is the largest language model in the world, also largest model in general. And for our competition, which I'll speak about in a moment, we give credits to OpenAI to use a few of their products. So I hope you'll have fun doing that too. This is going to be less fun than the video, but I want to make sure you guys understand what machine learning really is. If you go work in industry, most likely, if you don't work at a top research lab, you're going to be looking at something like this. Some company has a bunch of data that looks like this, and it's in a table, like an Excel sheet, and they're going to give you this data, and what they want as output is a model. And you can think of a model, a machine learning model, as a function or a program that takes in inputs and gives out an output. So in this case, you're going to, the data points are the income, weight, and age of different people, and eventually you're meant to generalize from this information. So you can see that if you generalize properly, if you give the model 75K and 190 pounds, it should say 23 years because that's in between the 20 and 26 years. And that's like approximately a linear relationship. That's the kind of thing you'll be doing 99% of the time. It's very boring, but if you can do these tasks well, you have a bright future. Machine learning, that's the core of machine learning, but it turns out that most of what you do as a machine learning engineer isn't just plugging this data into a model, but it's arranging the data into this form, figuring out what sorts of things are important to collect data on, cleaning the data, getting rid of missing values, creating features from the data. So maybe instead of giving the model annual income and weight separately, you give it some third feature, which is annual income times weight. So the feature doesn't, so the model doesn't have to worry about learning complex relationships between many features, but just needs to learn the relationship between two features, this new feature you generated and age. That's the kind of thing a machine learning engineer will spend a lot of time doing. So in machine learning, what you're doing is you're taking data and the output. In the case before, annual income and weight are the data, the output is age. You're putting it into a machine learning system, and at the end, you're getting a program, and that program is going to make predictions. You're going to give it income and weight, and you're going to get age. This is different than traditional programs where you give it data and you give it a program and then you get an output, which means the engineer needs to explicitly write a program which does something with the input features, with things like income and weight. So this is a really useful model to have in your head. So what kind of machine learning algorithms are there? Well, there's linear regression is a very simple form of machine learning. Lots of statistical learning is machine learning. Another type of model you might find a lot is a decision tree model. So if you've ever played the game 20 Questions, the system trained there is using a decision tree. You ask a series of yes or no questions, and by doing so, you roughly cut the search size in half each time. So if I were trying to find a human being and I said, is it male? Is it female? Okay, well, if someone answers that question, even though you asked only one question, you cut the population in half. Then I say, are they over 40 or under 40? And then I would cut the population in half. So, you start at 6 billion, then 3, then 1.5. And it turns out you only need to ask a few questions before you're added individual. So decision trees, the way they work is they figure out which questions to ask to discern a particular category. And on the right here, we have something called k nearest neighbors. So what you're seeing is a bunch of data points being clustered into groups. So at inference time, when you want this model to make a prediction, it's going to look, if you give it, again, to use our running example, if you give it income and weight, it's going to look in the table and say, who has a similar income and a similar weight to the person whose age we don't know? And then we're going to guess the person's age who's closest to our person. It's very naive, but it works really, really well. Okay, so how do you learn machine learning? If you work really hard, you end up working for this guy at the bottom right. It's actually more straightforward than you think. So the first thing you really need to learn is you have to learn how to program. Python's probably your best bet. About 65% of machine learning systems are written in Python. The rest are probably written in C++. You guys know how to learn to program. It's all over the internet, but YouTube, Coursera, work on projects. The other thing you need to learn is SQL. And SQL is the language you're going to use to interact with data. In the real world, even if you're a great machine learning engineer, but you don't know anything about interacting with data, you won't get a job. No one is going to give you the data for you. You need to fetch the data. You have to query databases. You have to transform the data. So you really have to know the data side of things. And the same recommendations. You're going to use YouTube, a boot camp, or online courses. One of the best books out there is Introduction to Statistical Learning by Dibshirani and several other authors. This book will kind of outline things like decision trees, how they work, how they're actually implemented, how general ML systems are built. So for instance, one way we would assess the quality of the ML system is to take our data and leave a tiny portion out that we don't train on. And at the end of training our model, we'll go ahead and check its performance on an untouched testing set. That's how we get kind of an independent verification of the quality of our model. This book will kind of go through concepts like that, the general workflow, all sorts of important statistical ideas. Okay. The next thing you can do is you can use machine learning libraries like scikit-learn to build small projects. Scikit-learn is pretty much an off-the-shelf tool. You can build a machine learning model in about 4 lines of code. Really powerful, works really well. If you want to learn deep learning, you should take Andrew Ng's deeplearning.ai courses. He has a bunch of free courses. And then you're going to need to learn a deep learning framework, probably PyTorch or TensorFlow. Those are the 2 most popular. That RL video where we saw a bunch of the blue and red people running around, that was written in PyTorch. So OpenAI, premier AI company, uses PyTorch. Make sure to experiment around, build good projects. And then at the end, if you actually want to make a development in machine learning theory or start to build really state-of-the-art models and make improvements, then you need to learn some mathematics and statistics. And really quickly, don't let this scare you. Calculus, you're going to need to know statistics, and then things like convex optimization, information theory, theory of probability, maybe even to the graduate level. Those are the things that are going to help. Differential geometry, the list goes on and on and on. It's going to get tricky. The more abstract math is not going to be useful for you. So even if you were a math major and you learned algebraic topology, it's not useful. Really, maybe I lost connectivity with you guys. Okay, we're back. All right, so what about deep learning? Deep learning is a type of machine learning, very avant-garde, very important. How should we begin? Deep learning actually has an old history, but was pretty disregarded by academics and industry until about 10 to 20 years ago. And that's because deep learning requires very fast machines and lots of data, two things that we only have now. A neural network is a collection of neurons. They're arranged in layers. And at the input layer, you would get things like annual income, weight, the kind of features, the things that go into as inputs to your function. The inputs to your function are at the first layer, and the output layer would have the outputs of your function. In our case, it was age. Every neuron starts off connected to every other neuron and has a particular weight. And I'll tell you how the computation's gone in a second. So the internal structure of a neuron is as follows. Basically, a neuron takes all of its connections and it takes a weighted sum of all the values passed from the neurons it's connected to, and then it passes that weighted sum through an activation function. I'm kind of glossing over this because it's going to be hard for us to really get into the weeds here, especially since we can't interact one-on-one, but this is pretty much what you need to know, that a neural network is composed of layers of neurons. Each of those neurons is connected to all the neurons in the layer before it and the layer after it. A neuron, to produce its output, takes in a weighted sum of all its inputs and passes it through an activation function. We'll speak more about activation functions later, but pretty much they're functions which output a 1 if a threshold value is met and output a 0 if the threshold value isn't met. It turns out that you need these functions because they're nonlinear. If you have no activation functions, neural networks can only approximate linear functions. So that brings us really gradually into this next slide, the universal approximation theorem. So this is what I mean when you need to actually learn some mathematics to do deep learning. You don't need to know this in industry. This is if you're academic concerned with machine learning theory. You're going to need to know some real analysis. You're going to need to know some topology, complex analysis in certain parts. This is a scary theorem, but all it's saying is that take any well-behaved function, and if you make a neural network sufficiently wide, that is, it has enough neurons, then you can approximate it to arbitrary precision. So why is this? Why do we care that that's possible? Well, pretty much any behavior or program in the world is a function of interest. So this function that maps income and weight to age, this is a function. Maybe we care to learn it. We need to know that it's possible for deep learning, for deep neural networks to learn that function, and it turns out it is, as long as the network has enough neurons. Now, this theorem doesn't tell you maybe the network needs billions of neurons. Maybe it needs trillions. Maybe you need more data than we'll ever make in the lifetime of the universe. So it could be that the function you're modeling is too complex, or whatever the case may be, but it does give you a little theoretical comfort to let you know that neural networks can pretty much approximate any function. Okay, so how do neural networks learn? What you're seeing now is something that's known as a loss landscape. So you're looking at the surface of a loss function. What's a loss function? When you make a neural network, you're going to pass some data through it, and you're going to make predictions. Depending on how accurate your predictions are, you'll get something that's called, you'll get an error term or a loss. It tells you basically how well you're doing, how good your neural network is. Now, this loss landscape tells you how big your error is relative to your parameters. So as you change the weights and the strength of the connections between neurons, your error is going to change. So I'm just going to repeat that. Neural networks make predictions by fine-tuning their parameters, make accurate predictions by fine-tuning their parameters. Data changes the parameters of a neural network, the strength of the connections between neurons. So in this case of a bowl, let's assume that's what the lost landscape looks like. It's what's known as a convex lost landscape. In this case, you might say, suppose you're at a random point on its surface. Let's say you're hiking, you're on a mountain. How do you know which way is downhill? That's pretty much the question of interest. And one way of getting to the bottom of a mountain is to just look around you, see the steepest, the area where you would decline the steepest and traverse in that direction. So walk in that direction. So pretty much just walk downhill. So that's the first strategy. And if your lost landscape looks like the picture on the left, well, it's going to work. And you're going to minimize your loss, which remember is error. So by minimizing the error, we get a really successful neural network. If your lost landscape is messy, like on the right, even if you walk downhill, you may not always arrive at a global optimum. You may get stuck in a local minima, in one of the local minima. So this little pocket here is not as low as you can get. This doesn't minimize the error as much as you'd like. This other region, this purple region, is the lowest. But you can get stuck in one of those pockets because that simple rule, walk in the downhill direction, will get you stuck in a little pit. You can read all about this later. That's just a general idea. So let's just review quickly what the elements of a deep learning system are. So you have a neural network, which is a bunch of neurons arranged in layers. You have a loss function, which tells us how bad our current model is. You have an algorithm or a rule to train your network. In our case, it's going to be gradient descent, which is the rule that you should walk downhill. And then you have some data you want to train on. So to train it, you're going to randomly initialize the network, and you're going to keep training until the loss is sufficiently small. So what you do at each step is you figure out how bad we're doing, and then you move in the direction that will decrease our loss the most, and that's the downhill direction. So in the simple terms, we're going to make some guesses. We're going to check how bad our guesses are, and then we're going to adjust the guesses we make based on the feedback we get. So here we're going to now have an interactive demo where we're going to train a machine learning model. And I'm going to put this, I'm going to do the live demo, and maybe you guys can follow along after. Okay. So let me know if you guys can see this. All right, so we'll have this one class called teddy bear and another class called Nintendo. And I'm gonna turn off my camera and upload some images for you guys. Oops. So here we're providing all the training data it might need to recognize me with the switch controller. I'm giving it a lot of, oh, that's, okay, well, it's gonna make the opposite prediction because I've labeled it wrong. 1 second. And then we'll do the same thing with the teddy bear. We're giving it all the orientations it might need. Okay. And then we're gonna train our network. So almost done. Hold tight, guys and girls. All right, so we should be able to see the output. So this for sure, it thinks is Nintendo. And it also thinks blank me is Nintendo because remember we took a few bad images. When I put the teddy bear, it knows it's a bear. Now if I put both, maybe it's going to be slightly confused. Maybe not. So anyhow, you can see it's actually really successful. You give it enough training data, Nintendo, bear, Nintendo, bear. Very fast, and we only gave 100 samples or so. I'm going to send you the link in the chat if you guys want to experiment quickly with this. I'm going to give just 5 minutes because we don't have that much time left because I want to talk about the competition and have time for Q&A. So just 5 minutes, you guys can train your own ML system. The link is in the chat. You could maybe have it just discern between your phone or whatever else. Okay, so good luck. So our competition details are on Kaggle. You can find the link to the Kaggle on DevPost and also on Discord in the Elemento text channel. Kaggle is a site that's used to host all sorts of machine learning competitions. In general, it's a great way to learn. If you win the competition, for instance, Zillow offered an award, Netflix offered an award, $1 million prizes. So if you can build a system that's better than theirs, even if it's from your basement, they'll give you $1 million. And there's nothing aside from your model accuracy that counts. So, and you can do this with off-the-shelf tools with your friends and still win amazing prizes, get a lot of experience. You'll also use Elemento's platform to host the model and help you develop the model. You can find links to our platform, again, in the Discord, in our text channel, I think also on the Kaggle. You can find help in the Discord, all sorts of links. So what is the competition? We're going to be looking at NFTs, very popular NFTs, and we're going to be trying to predict the movement of whales. So whales are the movers and shakers in the NFT space. They're people who do a lot of volume, big transactions. They're the ones that are really determining the price of the NFT. We're going to find some whales, and we're going to predict whether they're going to buy or sell a particular NFT project. If you can do this well, you can make a lot of money by piggybacking or save yourself a lot of money by withdrawing your funds right before an NFT whale decides to sell all of his NFTs. And what you can win? OpenAI credits, the company responsible for that, a fun little hide and seek demo, and you're gonna have access to GPT-3, which is again the most sophisticated language model in the world. The credits you'll win are sufficient for writing thousands of articles, hosting chatbots. Really, hundreds of startups have been formed just using the GPT-3 platform. And then you're also going to use you're also going to get just by participating Elemento credits, and you can use those to host your model once it's developed. What's nice about that is you have all the ingredients that your startup will need for a minimum viable product. So you'll have state-of-the-art models, you'll develop them with our platform, and you'll host them with our platform. And that should be enough to raise money, to do demos, small launches. But remember, these awards are team awards. So the amounts you see on DevPost are for the team. You can do this project in small teams. I don't think they require teams of 10 people, maybe 2 or 3. So you're not going to be splitting the prize with a lot of people. So quickly, I guess I'm open the Q&A just through the chat. Anything you want to know, let me know. Career advice, how to learn the mathematics you need, and we'll open it up for 10 minutes. Yeah, so as far as mathematics, if you want to just be an engineer, machine learning engineer, you need to have taken calculus 1, 2, and 3, so differential, integral, and vector calculus, or multivariable calculus. You'll need to have taken linear algebra. You'll need to take probability, and you'll need to take statistics. Those are your essentials. Now, mind you, you can be a machine learning engineer without ever having taken any of those courses and never reading them. The tools actually don't require it, but you will be a much better machine learning engineer if you learn linear algebra, if you learn statistics, if you learn probability theory. And they're all relatively easy to learn. Real analysis, information theory, asymptotic theory, large sampling theory, point estimation. These are all branches of statistics. That's if you're going to be a researcher. You're going to do some really high octane stuff. But for the run-of-the-mill stuff, you can just use the tools, learn on YouTube, and that's sufficient for building state-of-the-art products. You can have a startup just with like open tools and like a little bit of sweat. So you don't need to be an expert by any means in the mathematics to develop great products to solve real world problems. But you have a better chance of getting hired if you know the nitty gritty. The other thing for getting hired, because it's tech, is you need to know data structures and algorithms. So you're going to need to take a data structures and algorithms course. And if you don't want to do that, just get a LeetCode premium subscription and just do 500 LeetCode problems. And you can see which problems people are from the company you want are asking, and you'll do well on those interviews. I mean, really, like starting salary like 200K in California. So, and that's exclusively from just studying LeetCode. You don't need to do anything else to get hired there. Anyone have any other questions? Yeah, like two or 3 years ago. At what point in my life did I decide to pursue this topic? About 3 years ago. I started in agriculture, building systems for mold detection using computer vision. So it takes in an image of a mushroom bag and tells you whether it's infected by mold. And then I just went from there, and I took all the open courses. I took a boot camp. I read the research. I knew the mathematics already, at least to the graduate level from the undergrad, so that helps. But you can do it like in about 6 months to a year. You can make yourself an employable machine learning engineer. So never be discouraged by that. Like you just got to work hard. What are the pros and cons between Python and C++ for ML? You want to learn Python, even though it's like, oh, baby language, you don't have to specify your data structures. It's whatever type, it's interpreted, it's slow. It doesn't matter. Like every single cutting edge platform is typically built in PyTorch, which is a Python library, because all the important C++ stuff and all the stuff going on under the hood is compiled. It's just that the high level stuff is done in Python. So definitely Python. C++ is kind of like if you want to do general software engineering also, and kind of broaden the scope of companies you can work for, because about 30% or 40% of the companies want you to do C++, but Python is probably your best bet. So definitely, unless you already know C++, stick with Python. And also, you give yourself flexibility because there are more development positions in C++ for things like game dev and all the rest. Python, outside of ML space, you can do everything with it, but it's going to be more popular, for instance, for web development than C++ will be. So it just depends what you'd like to do throughout your career. One thing I will tell you guys in terms of career advice is to do the data engineering side of things. Make sure that you learn SQL. Lots of people end up working for a year or two as a data engineer before transitioning to data scientist and then machine learning engineer. And then the hierarchy after that is research engineer and then research scientist, principal research scientist. If you become a research scientist at a top ML company, you can expect $1 million, $3 million a year in salary. And they have their PhDs, but there are researchers without their PhDs. So that's kind of the like ML hierarchy in terms of easy to difficult for getting hired. Could you clarify your question, Alexander, for me? You're developing machine learning software from the ground up? As far as startups go, I'll tell you, like, using PyTorch, and also there's something called Fast AI. I recommend everyone here takes the Fast AI course. Yeah, so if it's fast AI and it's from the ground, if it's a machine learning startup, you can use fast AI. Fast AI has state-of-the-art models, really simple to use. You don't really need to know the theory. You'll have a general understanding of what's going on, and you can pretty much build any product you can think of with it. If you need more flexibility, you're going to have to use a PyTorch. So definitely learn Fast AI and PyTorch. Fast AI has like a structured course for you to take. There's lectures, there's exercises, there's homework. And then you eventually can learn PyTorch. Harder to learn PyTorch, more going on. You're going to need to know programming. So, you know, pros and cons, but definitely learn both of those if you're interested. Also, incorporating AI into your startup is the #1 way to get funded these days. It's the hottest space. If you just put AI in your startup, people will throw money at you. So there are reasons other than interest in the field for learning the basics, and also just to be literate in the technology space. Every single company is using ML for about everything you can think of. You can't do statistics without doing ML, machine learning anymore. So you have to learn it. What's my favorite part of machine learning? Definitely. So one thing that's interesting is something called unsupervised learning. I should have mentioned this to you guys, but basically, in this case where you have labeled data, that is, you have input and output pairs, you're doing something called supervised learning. In unsupervised learning, you're not given input-output pairs. You're just kind of given a bunch of data, and your job is to find structure in it. And that is the area of machine learning that still needs to grow. And that's actually how humans learn for the most part. So if you wanted to build a deep learning model for classifying a horse, for example, for taking an image and deciding whether or not it contains a horse, you would need 100,000 to 1 million images of horses to understand. If you go to a child who's never seen a horse, you point to a horse, you say, that's a horse. Every single time after that, he'll know whether what he's seeing is a horse or not. He only needed one example. And that's because humans don't learn by taking 1 million input-output pairs. They take something and they create really rich representations of it in their head. And that's an unsupervised learning task. If you can crack unsupervised learning, you'll solve every world problem you could imagine: hunger, aging, disease, you name it. If you have to deploy an ML project, do you need to install all the packages used in the project? And which is the platform to do that for free? Okay, so I would say Google Colab for testing. Google gives you access to their tensor processing units, which are special processing units, kind of like CPUs, like GPUs, for doing machine learning computations. You can use it for free. They have all the packages downloaded. So yeah, that Colab is the best. As far as a demo platform, I wouldn't know for sure. But again, you can use our platform with the credits from the competition to host your work. And guys, I'm going to be available like on LinkedIn, on Discord, if you guys want to keep talking. If there's anything I didn't cover, you want any career advice with your studies, help with the competition, I'm going to be around. But I want to thank everyone for coming. I had a great time doing this. I'm sorry I wasn't a better host. It's hard to explain deep learning, but thank you all. Thank you all so much.
Thank you, Ahmed.